I'm going to be much more concrete, a little bit talking, introducing the scientific aspect of what we do, and also the kind of spin-offs that come from Texas. But I started myself. I'm a faculty here in aerospace. I started about 7 years ago, and I was very motivated by kind of the demographics. In this chart, this is from a European company called Apptronik. By age 80, unfortunately, 42% of us are going to be hardly mobile, and this means that a lot of robotics can play a substantial role on improvements upon kind of our daily needs, and this brings kind of the ideas that I play with symbiosis of robots and humans in the form of humanoids, in the form of exoskeletons, what I call the field of human-centered robotics, which are systems that are mechatronically fairly complex, but at the end of the day, the equation we're trying to solve is productivity. Whatever that complex forms, and mobility and manipulation and autonomy ultimately has to be productive, or has to allow us to be secure, healthy, have social comfort. And productivity is a big name for me. Depends on the industry. Disney productivity, the world of robotics, means entertaining. Industrial productivity means perhaps number of parts per hour, per investment, and so on. But NASA, which I work a lot, productivity in an EVA exploration might mean the dexterity of wearing a suit. And we have to fulfill robotics, exoskeletons, and so on, have to fill these measures. And for that, I get inspiration for field from behavioral sciences in efforts that those people are trying to make into modeling cognitive behavior, doing inference over cognitive behavior, perhaps in states like confidence and motivation, and in which ways we can use robotics and control theory to intervene to the way people end up doing things more effectively, more productive. These are some of my students playing with productivity models as dynamical systems influenced by a workload on a human, by the own state of the system. And we use ultimately to, as a proof of concept, to see how we can do this inference. In this case of being unproductive, the robot actually is looking away. When you look at the robot, we have a model of how upset the human is. It was not my choice, it was my student's choice. So part of it, the students do, is play around. The robot is kind of turns the head when basically on these kind of ideas. And ultimately robotics, and I come from Silicon Valley industry, into productivity of robotics, but productivity in the future might mean the robots have to predict more of what's going to happen in the future, and they kind of have to anticipate and then fulfill a task, a demand in the near future, as well as instantaneously, right? There's a little bit of the shared economy as well of robotics. A lot of the equipment that we do here, we hardly use it. We invest a lot of money, so I worked for a while on opening up
this is a Coral test. We have just optimized the robot model so that it appears on the cell phone.
Systems. Here we have
more efficient
process technology, simulations on your cell phone, very cell phone oriented. We're able to control some of the assets.
So now Luis is going to go ahead and control the robot.
Dreamer, for instance.
First, let's go ahead and make it go into the ready position. Okay, so he clicked a button on the screen.
Oh, and I'm just going to skip it here, but from an academic standpoint, why people would connect to a robot? Well, content is very important. In this case, educational content, but training content also for companies. They want to have their people, the technicians, the engineers more involved. So we focus on this browser-based content for studying dynamical systems, control processes, vibration theory, and so on and so forth. And one of the pushes that we have had in UT is to create companies. In part, I think, answering the question about devices, that it is to some extent hard for us to maintain very complex devices, but we ambition to create very complex devices. One of the things we have been doing, a lot of the faculty here is create companies. I am co-founder for a company called Apptronik. We do develop these devices, and those are industrial grade. They can function for a long period of time. They can be maintained, and so on and so forth. These are devices that we first developed for NASA. These are deployed. We build robotics facilities as a company, as a university. This Houston Tillotson is a historically black college. I want to be skipping. Another thing that we do is we create courses based on what we believe the future industrial needs are going to be. In this case, on prediction of some of the states of the human, and then doing kind of some of the control processes for how robotics and human interaction can blend together. A lot of the focus that in my lab I have, but I think I speak in behalf of many of the faculty here, is on collaboration with industry and then with great laboratories like NASA. These are some of the things that I did, for instance, my lab did into high power density actuators here in the ankle for some of the X1 MINA exoskeleton. And we also built parts of this wonderful system used for Mars exploration. We have multiple of our actuators. This is one of our actuators, for instance. We do a lot of compliant control, which is maybe some of the things that we're going to see in the industry in the near future. We do a little bit of field robotics. This thing is commercialized nowadays, called Valkyrie. And another thing that this university has is this capability of creating companies. We are supported by the Dean's Office. And one of the things that myself, here we have actually the CEO of my company, Bill Welch. We develop a company where we focus on the exoskeleton industry for our space and also for defense. This is one of our actuators developed at UT and ultimately recently just became a patent and then is being sold to companies that do exoskeletons, for instance. These are force-controlled devices. This is a new series of it, partly also developed at UT. It's a liquid cool, very high power density, so the gameplay here is something really small that kind of carries very heavy weights and therefore allows kind of these dream devices. We do a lot of also studies, both academic and also industrial, on efficiency, communications, and so on and so forth. And this is, I think, my last slide. And then we do also kind of system level things. Also, these are work together with companies and UT, and then we develop much more sophisticated devices. Again, this teaming with companies allows us to have much more of an impact into kind of larger projects. And that's about all. Thank you.